Hello everyone. This is a brief introduction to our paper, Entity-Based Denoising Modeling for Controllable Dialogue Summarization. I'm today's presenter, Zhengyuan Liu, and this is a joint work with Nancy Chen. We are from Institute for Infocom Research in the Agency for Science, Technology and Research, Singapore. Text summarization is the task of compressing a piece of text to a more concise version, while preserving the information of the source content. There are two summarization paradigms, extractive and abstractive, and the summarizers are used to process various kinds of source content, such as news documents, scientific articles, and meeting transcripts. Before moving to the methodology description, we would like to spend a bit of time here to discuss the difference between dialogue summarization and news summarization. Extractive approaches, which are straightforward and can provide reasonable results on monological summarization, but they cannot perform well on summarizing conversations, such as meeting transcripts. As example shown in the figure, the pieces of useful information are often scattered across multiple conversation turns, and summarizers need to aggregate them by comprehending the context and paraphrasing it. There are some common features in human conversations, such as multi-party interaction, speaker role shifting, and the referring expressions. Additionally, utterances are usually in a direct narrative style, which cannot be copied to form an extractive summary without any paraphrasing. Recently, controllable dialogue summarization has started to raise more research interest. Most summary generation tasks are constructed in an under-constrained fashion. In their corpus constructing process, only one reference summary is annotated. Models with a general summarizing purpose only provide summaries in one style, and may overlook information that is important to a specific person's perspective. Personal name entities play important roles in conversations, as well as the summaries. As the aim of dialogue summaries often focuses on who did what, and the narrative flow usually starts with the subject, often persons. Thus, the generation process can be modulated by personal named entity planning or prompts. For example, as shown in the figure, a controllable system can produce different summaries based on the specific perspective prompts. In our reference summary analysis of the SAMSum corpus, 19% of the human written summaries start with a personal named entity. Here, we use a single entity prompt for controllable dialogue summarization. One specific personal named entity is used as a conditional signal, and it is concatenated with the source dialogue content, fed to the summarizer. We observe that there is a positional correlation between the entity prompts in reference summaries and their occurrence in the source content. As shown in the pie chart, in the SAMSum corpus, 62 reference summaries start with the first occurred personal named entities in the conversation, and this number reaches 94 when we count the first two personal named entities. The aforementioned imbalanced positional distribution demonstrates a limited annotation diversity. Each source content only has one reference summary in existing corpora, and this leads to the first challenge of training models for controllable dialogue summarization. Moreover, hallucinations in automatically generated summaries raise concerns about the usefulness and reliability of abstractive summarization, and are very challenging to eradicate to rural approaches. In dialogue summarization, hallucinations often come from the misassignment of personal named entities. Inspired by the denoising sequence-to-sequence pre-training schemes, here we propose an entity-based denoising model to detect and recover the incorrect personal named entity tokens. Compared with the binary classifier for factual inconsistency, the sequence-to-sequence framework supports revisiting summaries via post-editing. As shown in the figure, to construct training samples for entity-based denoising, we conduct text perturbation on the reference summaries. More specifically, we first extract the full list of personal named entities from each source dialog, and then mask them or replace them with another random selected entity in the dialog. We then fine-tune the sequence-to-sequence language backbone for denoising modeling. Unlike the left-to-right auto-regressive generation, the denoising backbone can utilize the bidirectional context for both dialog and summary sequence. We leverage the entity-based denoising model for controllable dialog summarization. The denoising model can be used as a reference-free discriminator to validate the beam search candidates. Following previous work on two-stages summary ranking, we use diverse beam search as a sample strategy. For each candidate generated in beam search, we masked all personal named entity and feed it to the denoising model. If the output is identical to the candidate, it is regarded as a validated summary. Then the validated samples, which rank highest in beam search, are used as additional training data. In addition, since the denoising model learns to correct the entity-based perturbation, it can also be used for summary post-editing. Experiments are conducted on the SAMSum dialog summarization corpus to evaluate the controllable generation under the matched training and test condition. We first conduct evaluation on summaries with the same entity prompt as the references. As shown in the table, adding the conditional data augmentation to all selected language backbones brings improvements on both lexical and semantic metrics, and they improve the entity-based accuracy. As a single reference summary cannot be readily used for diverse conditional evaluation, to simulate the practical controllable scenario, we build a subset with distinct prompt, where a generation by a general-purpose model and the reference summaries start with different personal named entities. As shown in the table, the base model with our proposed methods achieves higher performance. Here are some key takeaway points. Dialog summarization often focuses on who did what. Thus, controllable summary generation can be modulated using personal named entities. Reducing the misassignment of personal named entities in generated summaries can improve the factual consistency. Our proposed entity-based denoising modeling is used for beam search candidate validation and to further augment the training data with diverse conditional samples. Moreover, post-editing approaches are beneficial for improving the generation quality. This is the end of our presentation. Thanks for your attention. For more details, please refer to our paper. Thanks.